All right, this is lesson 2-5. We're on standard F, basic derivatives. Our title today is E and natural log chain rules. So the last two lessons, 2-3 and 2-4, we've done power chain rules and advanced power chain rules. So now we're doing E and natural log. We're going into our log house and our E house now. All right, so here's the setup. You go ahead and pause the video now and get this set up. And now that you've unpaused, we are going to knock them down. All right, so powers. What does a power look like? So powers look like this. 4x to the power of 2. It looks like this. 3 times the quantity of x plus 2 to the power of -4th. It looks like this. -1/2 times 2x to the power of anything like a third here, as long as it's a number. So the key thing to think about here is the variable, where x or wherever the letter is, the variable is in the base. So variable in the base. So the general way of writing this, I'm going to keep it in blue, it's going to be like this. It's going to be some number, like a half or 3 or 4 out in front, and then you're going to have some base to the power of some number. And this guy right here, we'll even label it, this is the base. This is where the variable lives, somewhere down here. The variable lives somewhere down here. N, if you want to write the notes here, that just stands for a number. Stands for a number. I don't even want to write out number. I'm just going to do an octothorpe or a pound sign, whatever you want to use. And that's a very lazy pound sign. That's better. All right, so that's a power, but what's an exponential? So let's look at an example of that. Exponentials, 3 times 2 to the power of x. Oh, look at where the variable is now. Let's check this one out. -4 times 5 to the power of 2x minus 1. And all of that is to the power. Maybe I should put a parenthesis up here. Another one. 1/2 e. I should put parentheses around these. 1/2 e to the power of x squared. All right, so notice that in these cases, and I hopefully have enough room, maybe I should move all of these over a little bit, technology. These should all be moved left, so I have enough room on the right-hand side to write down our rule, the variable in the, and you guys know what to say here, it's in the exponent. I hear a lot of people screaming, oh, it's in the power. That works too. So again, I guess I should have labeled our A over here, because our A over here is slightly different. This A on the left-hand side, this was, we just call this a coefficient. It's a number in front of what we're looking at, so this is a coefficient. And the number over here, so if I have like an A times e to some power, while this is still a coefficient, it's more specifically the starting amount, or where the y-intercept usually is. So I'm going to call this guy, this is the start amount. So if this was 5, then the y-intercept would be 5. All right, so E again, this guy is now the base. And you can also maybe think of this as the multiplier, the thing that's being multiplied over and over. So maybe in here I'll write multiplier. Multiplier. Make sure I can spell. So I want to fill in the left-hand side here too, because E is special. Remember, our main topic here is E. The derivative, d dx of E, the derivative of E is E. It has a special property. It's equal to itself when you take the derivative. Pretty cool. Let that sink in. So I also want to write something else. So let's write this down. In order to distinguish the power and the exponent, so distinguish between powers and exponents, so I can just say between, BW, between, I'm going to abbreviate everything so I can fit it in, between power and, that's an and sign, and exponent. Look where variable is. So if the variable is in the base down here, then it's a power. If it's a variable that's in the exponent, then it's an exponential. And I didn't formally talk about this yet. So when we are in calculus in this AP class, we're only going to be dealing with an exponent where it's a base e. We don't have to worry about doing 2 to the power of x. All right, I'm going to go on to the next slide, so go ahead and pause it here if you need more time. Here goes the next slide. Okay, so our next slide, I want to call this the exponent base, or E maybe chain rule. So exponent chain rule. Let's write that down. The exponent EXP chain rule. And if you don't like exponent, maybe you want to write here in notes that exponent, whenever we're dealing with exponent, just as I wrote over here, I'm dealing with base E. So this is going to be base E, exponent chain rule, or E chain rule. All right, so here is your rule. So let's give this like a giant star. So our dx, the derivative of some coefficient times e to some power, this is usually a number up here, this is going to be turned into the same thing, a e to that power. So keep it the same. This guy, make a note here, keep it the same. I'll write it out. Keep it the same. So you're going to do the outside, d outer. So, and this is when I say keep it the same. So this is, I don't want to write doubter, I want to do d outer, doubter. Doubter, keep the same, but then you need to actually find what dinner is. Remember, we take the derivative of the inside, and then you multiply it. This is a times dinner. You still have to find dinner. Dinner might be something. Remember, if it's complex, then it might have 2x to the power of 1. Our variable is up here. We'll find that the d inner in that case was 2 or something. We'll look at an example, but just know that the outside of base E problems, the doubter is going to be this guy right here. It's the same thing, a e to the power of whatever you started with. It is the exact same, and then you just multiply it by the dinner. All right, so I want to make a note here on the side before I move on that when I take the derivative, so d dx of f of some function, so f of u, so you're really just adding a prime. Let's write this down. Add a prime. Come on now. Add a prime and multiply by dinner. So this is the same rule. You're basically adding the prime if you have the prime number on the outside, the coefficient, and then you're going to multiply that by the dinner. All right, so whenever I have something like this where I have d dx, the derivative of some coefficient of u, so some function of u, where I have that function to the power of n, you first do the n and then you do the inner. This is kind of a review of Powerhouse. So this is multiply down, multiply down, just like you normally do. The n comes down, it's a times n, and then you need to subtract 1. So multiply down, subtract 1. I'm just going to say subtract 1. And then this is all review. I hope I'm making myself clear. This is just talking about what I've already talked about. And then after you multiply down and subtract 1, then you take the inner function. So if the inner function was 2x minus 1, then you take the derivative of that. So after this, I'm going to say and multiply by dinner. Multiply, just abbreviating here, by dinner. All right, so I want to go over some examples. Let's see that. So examples. Let's just do 2. So here's the first one. They take the derivative of this function, 2e to the power of 3x. Okay, what does that turn into? That's going to turn into, well, what's the outer function? So I want to maybe analyze this a little bit more. So outer, in this case, outer is 2e to some power, and then the inner is 3x. So from here, I'm going to take the d outer, so the doubter, and I'm going to multiply that by dinner. Here we go. Go ahead and try this on your own. Go ahead and pause it now. What is d outer? What is doubter? What is dinner? Fill those in. Pause me. Okay, so the correct answer here is doubter is 2e to the 3x. It's the same exact function. It's the same exact function from this rule right here. And then I actually take the inner function. Inner is 3x, so dinner is 3. So your final answer, if I simplify this, is 6 times e to the power of 3x. Let's look at another example. Example 2. Let's take the derivative of this function. I'm thinking negative this time, e to the power of x to the power of 2. I want to take the derivative of all of that guy. So what does it turn into? We know that the basic setup is d outer, or doubter. I always just want to write doubter. It's d hyphen outer, doubter. And I'm going to multiply this by dinner. Same steps over and over. Here we go. So, pause me, do it now. Give you some time. All right, so now that you've unpaused the video, here we go. Doubter is negative e to the power of x to the power of 2. It's the same exact function. Dinner is, the inner function is x squared, so the derivative of the inner is 2x. So my final answer is going to be negative 2x e to the power of x squared. All right. One other thing that we need to go over, let's see how much in the notes we have to do. I want to do our last rule with natural logs and then do an example, and then we'll be done. So this is going to be the last slide, and it's going to be nice and full. Here we go. Okay, this is the e, make my e better, e natural log, this is ln chain rule. By the way, something that you should know is natural log is really, you might have seen log. Log is with any base, so log with base e, that is equal to what we think of as a natural log. And you will only see a natural log on the AP test. Don't worry about log, but just for your information, that is what natural log is. So here's your rule. Second rule, second most important thing I can give you today. The derivative, d dx, of some coefficient times natural log of, I don't know, some inner. There's inner, u's inner. That turns into, and this guy can be confusing, so remember him, a divided by the inner, a divided by u. So think of this as, do quotes here, a over quantity, whatever quantity you started with inside the parentheses. All right, so examples. I want to do 2. So we'll label these examples. Here we go. Here's the first out of the 2. So I'm going to take the derivative of 2 natural log of x to the power of 3. All right, so what does that turn into? Remember, let's analyze this first one a little bit more. So what is outer? And what is inner? Pause me now, go ahead and find these. All right, now that you've unpaused, outer is 2 natural log of something. Inner is x to the power of 3. So we know our basic setup is going to be doubter times dinner. Here we go. Doubter is what? It's going to be 2 over something. 2 over, and it's whatever quantity you start with. Our quantity was x cubed. 2 over x cubed. And dinner, derivative of inner, is 3x squared. So if you multiply these together, and maybe I can simplify this down here. I should have done this in red. I'm going to go back and just rewrite this in red so it looks consistent. This is going to be 2 divided by x to the power of 3. I can't even make out the 3. Come on, Mr. Sindel, we got this. 2x to the power of 3, and then dinner is 3x squared. So my final answer is 6x squared over x cubed, which is not final because I can simplify that into 6 over x. All right, that was the first example. So don't forget dinner. Dinner is always part of the natural log house. All right, final example, and then you can do the summary. Final example, here we go. Number 2. So I want you to find the derivative. I want you to find the derivative of this long guy. Let's try it. Natural log of, I'm feeling, technically natural log should also have absolute values in it. I guess that's only when you take the, never mind. Forget that for now. I'll come back to this later. Natural log of 5x squared minus 3. Okay, go for it. You know it's doubter times dinner. I'm not even going to write it down here. We know that. I can set up the blue brackets, but I'm not even going to label them. You know what to do. Doubter times dinner, and I want it simplified. Pause the video now. Go for it. All right, here we go. So doubter. Doubter was negative 1 divided by 5x squared minus 3 times dinner. Dinner is 10x. All right, and class just ended for my prep period. So that is as far as we can get it, aside from just making sure that 10x is on the top. So the final answer is negative 10x divided by 5x squared minus 3. Done. Go ahead and write your summaries, and you guys have the worksheet. I will try to make a video for that worksheet.